Let's look at eliminations. Solve a system by eliminations. If you have a system that has like a negative 2y and a 2y, then you can get rid of that and solve for x. Okay? You really just have the one variable to worry about. So if you look at this, it has x minus 2y is equal to negative 19, but then it says 5x plus 2y is equal to 1. Well, then you're only having to solve one equation. You're only having to solve for x. So add the two equations together on both sides. Don't forget you have to add the solutions too. 6x is equal to negative 18. Well, when you use elimination, it's going to be really easy for you to figure out what x is. All right? You write the system so that the terms are lined up. And remember, this only works if you have like a negative 3y and a 3y, or a negative 2x and an 2x. Eliminate one of the variables and solve for the other. And of course, then you substitute the value of the variable that you got into the original equations. Say if you solve for x, just now we would have gotten negative 3y. Then we would have substituted 3y into our equation in place of x, and it would have made where we only had to solve for y. And step 4, make sure that you always write the answers in the form of an ordered pair with parentheses, x and then y. And always plug in 1 and just double check and make sure you've done your work right, okay? Here's an example. 3x minus 4y is 10, and x plus 4y is negative 2. So first, we're going to add the two equations together. See how we're lining them up. Look at this. The y's are gone. So we've got 4 x's. And here we've got positive 8. 4 times x is 8. Simplify the equation, solve for x, and of course you get 2. Now we're going to start all over. All right, there's one of the original equations, and now we know that x is 2. So we're going to say 2 plus 4y is negative 2. Subtract 2 from both sides. 4 times y is negative 4. Divide, find out that y is negative 1. Write it as an ordered pair. There's x and y. And then go back in and plug it into one of the equations. In this one, you can see we're getting rid of 3x. Add the equations together. Remember, don't forget the right side. Add them together. Remember, this is always going to go away. That's why it's called elimination, because you are eliminating one of the variables. Here we're solving for y. 3y is equal to 12. We know y is 4. Now we're going to go back and we're going to pick one of the equations. It doesn't matter which one. We're going to replace the y with 4, and now we're going to solve for x. So now you just solve it like a regular equation. So see, solving systems by elimination is super easy if you can get those good equations that give you the data you need for that. All right, see if I can pull up the second one. We're trying to, let's do by substitution. All right, there you go. You're not always going to be given the 3y, 3x. So substitution, you're going to reduce the system to an equation that only has one variable also, and then solve that by the methods. But now this one's not as simple as the eliminations. Step 1, yeah, you're going to solve for one variable in at least one equation. And you're going to substitute. You're going to solve that equation to get the value of the first variable and substitute that into the original. So let's show you what we're talking about. Okay, look at this one. See, you have nothing to eliminate, but you're going to multiply both equations. Both are solved for y, okay? So if y is 3x and y is x plus 2, we're going to we're going to replace y with 3x, or we can replace y with x minus 2. I'll show you what they're talking about. If y is 3x and y is x minus 2, we're going to replace y. We're substituting y with the equation. We're substituting y with 3x. So forget this equation. We're replacing y with this equation. With this value, because that's what y is. So if y is x minus 2, then 3x is x minus 2. And now then you just solve for x. When you solve for x, of course, you subtract from both sides so you can get all your variables on one side. And then you get 2x is negative 2. So, of course, we know x is negative 1. Now plug that one in. Substitute negative 1 for x. Put your y back in there. Y is equal to 3 times negative 1. So y is equal to negative 3. Now write it as an ordered pair. Substitute it into the equations and double check. Let's try another one, okay? Y is x plus 1 and 4x plus y equals 6, okay? So we're going to see there's y equals. So this is the same as y. X plus 1 is the same as y. So we're going to substitute this in place of y right here. We're replacing the y with this because this is y. So now then we've got 4x plus, remember this is also y, equals 6. Now combine like terms. You've got 5x plus 1 is equal to 6. Subtract 1 from both sides, divide by 5. Now x is 1. Now then all you've got to do is substitute 1 for x to solve for y. That was simple. Y is equal to 2. Now plug it back in and double check. Let's try one more before we move on. Here we go. X plus 2y is negative 1. X minus y is equal to 5. There's something you're going to have to do first. Solve the first equation for x by subtracting 2y from both sides. Look what happens when you do this. Minus 2y minus 2y. Well, now x is equal to negative 2y minus 1. Remember, we're just trying to get x or y on the left side of this and isolate it so that we can replace x or y in the second equation. So now we've got what x equals. So we're actually going to substitute this for x in the second equation. So here we go. Here's the x. We're substituting. Remember, we got x equals this. So now we're replacing this x with negative 2y minus 1. And then you're going to simplify. Negative 2y minus y gives you negative 3y. And now just solve by plus 1 on each side, negative 3y, and y is negative 2. Now just plug in, substitute, and solve for x. And now you'll get x is 3. So just look over this at your own pace. We're going to go to graphing now. In the graphing, I just want you to concentrate on two things, and that is, if it's a graph, find the y-intercept. And if it's a table, find m to get the y-intercept. I'll show you what I'm talking about. Whoops. Whoa, that's not what I'm talking about. Okay. Solve for one variable, of course. Substitute. Do you notice you do the same thing every single time? Whoa, I'm still on substitution. Sorry. We need to go to the y-intercept. This is the one I need. I'm just putting this together for you real quick so you can try to get your work turned in for me. There. I'm sorry. Okay. All right. Tell whether it's a solution of the given system. Well, when they give you an ordered pair, all you do is substitute and solve. So they're telling me that x is 5. So I'm going to plug in 5, and I'm going to plug in 2, And if it's right, then of course it's then it is a solution. If the ordered pair does not satisfy the first one, don't check the second one, because the only way that this can be a solution is if it satisfies X and Y. So if this is incorrect, then you're not going to go any further. See, right there, you're going to stop. A solution goes with the whole given system. All right, we're going to plug in a 1, and we're going to plug in a 3, and we're going to solve it, both equations, and if they're both checked, then 1 and 3 is the solution set. That means that's where the lines intersect on the graph. All solutions are going to be on the graph, and to find the solution, you just have to find 2 points on the graph. All right, the point 2, 3 is where these intersect. So as you can see, the blue, all of these are solutions for this. And in the red, all of these are solutions. Now, where they intersect, it means that is the solution for both of them. That satisfies both equations. Sometimes it is hard to tell. Look at this one. If you graph y equal x here, and y equal negative 2x minus 3, you can see how difficult that is for you to see when you graph the system. It looks like it's at negative 1, 1. But if you actually work it out, you want to make sure that it is. Because if you'll notice, sometimes it could be at a fraction. And remember, fractions can be solution sets. So don't always just assume that. Plug in what it looks like in the graph and see if that is correct. See, this one says 1/3 x. So you're going to rewrite the second one in slope-intercept form. Remember that? Y plus 1/3 x equal negative 1. And you're going to subtract. Of course, you're going to subtract 1/3 x from both sides and get y equals negative 1/3 x minus 1. This is the slope-intercept. Remember, y equal mx plus b. You should have learned that in the first semester. Y equal 1/3 x plus b. In this case, it's plus negative 1. This is your y-intercept. So that's what you're doing right now. And they graph with the graphing calculator. All right, solve the system by graphing and check your answer. Just substitute this into your system, guys. You can simplify it. You can use your calculator just to solve and make sure that it works for the system. And in this case, 15/4 for x and 9/4 for y make the solution set. Remember, graph it, make your XY table, or write it in, see, this is mx minus 1. This is y equal mx plus b, and this is in slope form also, because this is 1x plus 5. So you just graph the system by making you an XY table for each one, graph it, and where they intersect is the system. Is the solution. Double check it, make sure it works for both, and there you've got the solution. All right, solve this one. Make your table, 1/3 x minus 3. Rewrite the second one. Remember, you always want it in y equal mx plus b format, okay? Makes it much easier, because when you get the minus 3 right here, we know that when x is 0, y is 3 for this one. Y is negative 2x plus 4. When x is 0, y is 4. Use your graphing calculator if you have one. If not, set up an XY table and create 3 to 4 points, hopefully enough points to where you can find out where the intersection is. And there's your intersection for the graph. And then this one, this is simply an equation with variables on both sides, okay? This is going to be 14 plus 2x, or 2x plus 14, And on this one, it's going to be 3x plus 6. And you want to see when they'll be equal. So that's how you're going to solve that equation. Okay, I don't know if this was helpful or not, but I was hoping it would just kind of compare the three for you.